Jeffery's recording here. There we go.
All right.
That's it.
All right. Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady. Today's guest is Jeff McComb and Jason Crisp, and they're from Lisi Global. And we're here to talk about their new product that they're working with. And let's get into it, guys. Welcome to the show.
Hey, thanks a lot.
Thank you.
Appreciate it, Sean.
You bet. You bet. Well, look, I mean, we came across each other, I think, unpromptedly, but I think you guys were looking to maybe get some exposure in the market about your product. Let's talk a little bit about you let's let the listeners know a little bit about your product and tell us a little bit about, how you guys started this business.
Basically what we've developed is a technology that uses non-chemical application of energy directly to the soil to manage soil-borne pests and pathogens. So typically these are addressed through a synthetic chemistry, very broad spectrum, large effect chemical profiles that disinfect the soil to a certain extent. And we target a specific organism, find weaknesses in its physiology and anatomy, and use our profile to affect those processes and control the pest.
So you're basically electrocuting the bugs.
We'll go ahead and go with that. It's a slightly more sophisticated approach.
We do our best to make it sound more sophisticated than that. Anyway.
Shocking the crap out of them.
If you look at electrocution, it's really a thermal injury.
Yeah.
As the humans go. We're a little bit more specifically targeted than that, but it's electricity to manage soil pests.
I love it. And then, how'd you guys get into this product or, this business? Give us a little bit of background about your history before you started Lisi Global.
So we both have a different career paths. I've been in electrical engineer by training, but in clinical and biomedical engineering my entire career in healthcare settings. We co-own a medical imaging company. We work with high energy electronics and X-ray, sell, service, support, maintain that equipment. Really similar energy profile, very high energy density, high energy electronics. Jeff comes out of a motorsports background, so a lot of mechanical and logistics in that industry. We met at the Broad Ripple Brew Pub in Indianapolis.
No, Broad Ripple Brew Pub. There you go.
Yes,
shout out to Broad Ripple.
Shout out to the homies.
That's right.
And realized that we had a lot in common and started riding mountain bikes and obviously drinking beer and carrying on. Then brought Jeff into the imaging company a few years back. And this was already sort of in process. So the original kind of origin story, really quickly, Dr. Katerina Riga is an invertebrate zoologist. She's our third co-founder. She was doing nerve potential studies with a plant parasitic nematode, very small microscopic nematode. She was trying to collect data with this experiment. Every time she turned the equipment on, the nematode died. She asked for my help. I found out that it was putting a very small bias voltage across the nematode, really, really small amounts of energy and killing the pest. And I thought that if it could do that easily, why aren't we doing this as a mitigation strategy? And that kind of began the whole thing. We really quickly did the math and realized why nobody had done it as a mitigation strategy. Because to control that energy profile, the technology didn't really exist in a commercial level. So
I see.
For the last 10 years.
10 years.
Yeah, we've been just ramping this thing up, keeping the science very consistent and just running a thread through as we scale it. And now we're at a commercially viable product that we're deploying into the field.
Wow. Okay. So we're talking about direct energy technology, DTE, right? And, how does it work? DTS. Okay.
Yeah,
well,
DES.
Yep.
DES.
Basically, we take energy from any source. Right now, we're currently using batteries.
Okay.
And we stack that energy up in a very, very fast energy storage medium. We switch it at a very specific profile and deliver that directly to the soil. Disrupts neurological targets, does cellular electroporation. Depends on what our target is, what the pest is that we're going after, whether it's a fungal pathogen or an actual animal.
Okay, that was kind of one of my next questions. Like, what are the problems it can solve, and what type of targets that are you trying to, knock out?
Yeah.
What's the market space?
Man, it's pretty much everything. Pretty much every ag industry on the planet has some level of infestation that needs control. And more often than not, there isn't a chemistry available that's effective, that's available to them. So nematodes in particular, when you get into places where there have been, thousands of years of intensive agriculture, you get into Europe or Africa, South America, those places where pest pressures are just intense, so intense, in fact, that when you put a plant in the ground, the nematodes will come out of dormancy. They'll eat the roots of the plant and kill it. Just simply can't produce a crop. So, I mean, that was kind of the where we started, was around that nematode problem. Obviously, with a nematologist kind of leading the charge, that was a lot of our focus. But what we've learned as we've developed this and begun to deploy it is that nematodes are a big issue, but there are a lot of other issues out there.
There's other organisms that are also pests that are attacking, either turf or other agricultural, plants that are making it very difficult to treat, right?
Exactly. And so what we're doing now is keeping that focus on the nematodes, but also shifting our attention to, whether it's grubs or crickets. One of the things, obviously the goal for us right now is to deploy and generate revenue, learn what we can in golf turf. That's the direct turf branding that you see here. But with an eye toward agriculture in general. And so we cut our teeth in turf, where the infrastructure is not as we're not having to navigate infrastructure. It's it's a flat open field, so to speak. We could come in, dial in that energy profile that's effective for nematodes, and then we find that energy profile, fine-tuned, can target those other insects, those other organisms that are harmful to not just golf turf, but also other areas of agriculture.
Well, there's got to be there's a lot of really great applications, it sounds like, with this technology. And agricultural, and food security seems like one of the biggest opportunities to help solve some, problems, in that space. I mean, is the product being kind of focused, like you mentioned? You're going to get to agriculture, but right now you're doing a lot of proving it out on more turf right now. Is that let's take the learnings from the turf and then try to figure out better application strategies for the agriculture? Is that how you guys are approaching, or is it just like either way, either problem we're going after,
So from an engineering standpoint, in terms of how you get the energy into the soil, golf turf presents very few challenges compared to other row crops, vegetables, whatever what have you. So from this simple place where we're starting, where it's Jason engineering the electronics, I'm designing and building delivery apparatus. We can do that with our knowledge and background, our level of engineering and expertise. For golf turf, that's a relatively easy. I don't want to make it sound too simple, because there's a lot of nuance in there as well. But we've managed to make it so that we can deliver the energy without a lot of surface disruption, so we don't affect playability of the greens. And we can take the technology from the green to the fairway and pretty much apply it anywhere on the golf course where they've got an issue. So with that, we can dial in that the electrical profile, and then hopefully, and our goal is, we partner with an engineering, a larger firm, whether it's a Toro or a John Deere, something along those lines, and they take that engineering to the next level.
Gotcha.
Apply what they know and how that they can apply the
use
apply
it use it to design a better application process, right, to basically commercialize it in a sense. Exactly. Sounds like, right?
Yeah, for sure.
That's really cool.
And also, there's something to not lose sight of, is that even in turf, we've got the ability to displace millions of dollars of chemistry that they're currently trying to use to address this.
Well,
it doesn't have to go on the ground. Right?
Great point. Now you get into the environmental benefits of this technology, and really that was what really piqued my interest, to be honest with you guys, when I saw what you guys are doing from a sustainability perspective. To me, this is probably one of the biggest drivers. And I mean, it is of course to, address the pest issue, but oh my gosh, the sustainability benefits of using this technology over, conventional practices, by, chemical treatment, water usage, all those other things. I mean, that to me is the bigger payoff at the end of the day, right?
Yeah. And it's every cropping system, right? I mean, we're starting in turf because it's a very high value, very small footprint crop with tons of inputs. They're spending thousands of dollars a year in chemistry per green.
Mm-hmm.
And, don't lick your golf ball. Wash your hands before you eat your sandwich. I'm just throwing that out there to your listeners.
Yeah.
Don't do that. It's not a great idea.
Yeah.
Because that chemistry, by definition, if it's effective, it's toxic, right? Otherwise, there's no efficacy.
Yeah.
It has to have biological interaction.
Absolutely. Now, have you guys had any conversations with like the USGA and the Green Course section? Because I had an interview with one of their lead guys, Cole Thompson, who's over there, and that is one of their big tenets and directives, or I guess priorities with helping golf courses manage their business more sustainably.
Mm-hmm.
And they've got some digital technology that they use. One's called their Deacon tool. It's like a digital imaging type GPS type, tool. So it goes out and maps the golf course, maps the players, activity on the course, and they can understand a better way, or should I say, they can understand like where golfers are not going on the course, right? And they can take out some of the maintenance and management of that operation, because golfers don't even go into this bunker or this part of the course that you're actually maintaining and spending fertilizer and chemistries on, and watering and stuff, and you can take those out of play or stop managing them. And then I'm thinking, wow, this tool could also be an augmentation of the approach of their sustainability practice.
Yeah.
It's like, let's not use chemistries. Let's use, DES.
Yeah. And they're aware of what we're doing. And I think especially in the industry in general, everybody's just waiting for us to deploy. We're in a little less than a month. We'll be in South Florida because of various reasons, environmental. The climate is very conducive to these problems down there. And so they have the biggest pest pressure that we can address in that part of the country. And they're just waiting for us. I mean, there's a queue of golf courses that are waiting for our services. And the players in the industry are aware of what we're doing, and especially the ones that have that sustainability kind of mantra.
Yeah.
Like what you mentioned. They're aware of us. We've had conversations. They're supportive, but we're just rolling out. So they're
right. You got to give us a little time to kind of, start deploying and showing the benefits and the results. Right. I mean,
yeah, it's really that. And we've partnered with, the preeminent researcher in turf in South Florida. He's been aware of us for 5 years, very big supporter actually. And getting ready to collect data for a peer-reviewed publication, because the way our business model works, we start with the science and the engineering, and then we use that to get us, adoption in the actual cropping industry. So we go through the researchers. We've got a very strong relationship with the USDA. They've done our peer-reviewed publication that you guys can link to. They did all the science on that. We showed up, we treated, we left. So it's all very independently done and very robust in the science. And that's kind of how we've had to do it. When you create something from whole cloth that hasn't existed before, we don't have any publications we can go back and look at.
You need to kind of build up a bit of a library, right? Of some articles and some
hundreds and hundreds and hundreds of experiments over the last 8 years. I can't even tell you.
Right.
But I mean, that's how you do it. You start off with the raw science and you work your way up. So.
Right. No, I mean, this is great. I mean, we'll talk a little bit about the technologies that are, kind of used in with this whole product. I mean, are we talking GPS, or there's solar? I mean, you got battery. Well, I mean, how are you guys, getting in the field with us, and you guys engineered this? What's all involved?
Well, we start with a battery source, obviously an energy source, and especially the way battery technology has come to us, even in the last, 36 months. Yeah. It's been crazy. We've switched over energy storage modules twice in the last 24 months because the technology is moving so quickly. So we end up with a battery pack that's about half the size of a Tesla Model S as a reference point. Gives us a full day of runtime out of that battery pack. Charge it off of shore power. We've got some solar, but the energy density we're talking about is pretty high, so it would be difficult for that. Fortunately, where we're at in the Pacific Northwest, our carbon footprint is super low. It's less than 5% of our energy profile, so very carbon neutral if we charge it from the shop. And
that's good. That's great. Yeah. I mean, that's, people want to hear that. They want to see, well, what's my carbon impact by hiring you to do this? And all the sustainable impacts or benefits that I have by deploying this application. That's great.
Yeah, well, and other than the obvious benefits, we actually have done some measurements and show that we do fix a little bit of carbon in the soil. It's not much to be to really tout as one of our frontline reasons, but
yeah,
the way it does interact with the soil chemistry, we do end up fixing a little bit of carbon. But we just try and source the energy as cleanly as possible. We use it very, very efficiently because it's a very short path. So there's very few losses. The energy is applied directly to the soil, so the mode of action is very, very direct with the energy profile. It makes it very efficient. Of our cost of goods sold to deliver this treatment, the actual electricity is way down the list in the cost side. So very little amount of electricity.
So you've got like a device that rolls across the surface of the soil. Is that driven remotely? Is that driven, manually? Or how are you guys doing that?
We can do it in a variety of ways. Right now we have a robot tractor. So it's all electric. It does have a solar panel on it that will sustain it throughout the day. But it's GPS and has autonomous and semi-autonomous navigation modes. You can also drive it manually. It's very, very efficient and is very powerful for the size. But you can hook it to a traditional tractor. It's self-contained. So the batteries, all the electronics, the delivery apparatus is all one kind of box, one apparatus. And you can connect it to virtually any vehicle that it's normally used for farming. And just move it across. What we try and do too is we piggyback onto cultural practices that the cropping system's already using. So for turf, they do these slit aerations on greens and so I'm sure your listeners have seen, if they play golf, when they aerate, you can tell on the green. So we've just taken an aeration process that they normally use and piggyback our technology on top of it, use that as an opportunity to get the energy into the soil. And that way the cultural practices for the end user are the same.
It makes adaptation or adoption of the technology much easier when they see something that they're familiar with.
Yeah, because they're thinking, hey, is this going to disrupt or damage my green or my fairway or something like that? And you're like, no, look, it's just like it's barely noticeable, and you can do it at the same time you're doing your aeration, and you won't even actually know we're here, right? I mean, that's
and it's the same thing with any cropping system. We've worked with small berry fruit growers when they do the bed formation. It's a really great opportunity there to apply energy profile across that bed former and use that as your opportunity to mitigate the pests. Or with row crops, there's all sorts of cultivation and things that happen during the season. Another easy way to integrate our treatment into an already existing practice. That way they're not dragging the tractor through the field again.
I could imagine, like, if I'm a John Deere type company, right, and you're doing all these seeding or I guess cultivating of some sort of seeding, cultivating, that kind of stuff. There's got to be a way that you can develop an apparatus that when it's pulling itself across that soil, it's doing its discharge and then planting the seed and killing the bugs that are, I don't know if that's the prime time to do it. I'm not a agricultural specialist, but maybe, right?
That's our job right now, is to figure out what the answer to those questions are, because we're not sure either. We've got a decent idea, but we need to go to these experts, whether the agronomists that work in these industries, these researchers that work in these industries, learn about what their cultural practices are and do our best to adapt to that so that it is a simple, kind of a no-brainer decision to add our technology to what they're doing on a regular basis so that we can, try and eliminate some of that chemical applications that they're having to do to get the kind of yield that they're striving for.
Yeah, I mean, I'm thinking, yeah, like a Beck seed or Pioneer seed or Monsanto. I mean, those guys would probably really be interested in this technology.
We've had a lot of conversations with a lot of mostly the research and development arms of a lot of interesting companies and certainly universities. I mean, the academic world is a huge source of interest and enthusiasm. Because they know better than anybody that the amount of options that are on the horizon are very few, and the tools that they did have that were effective are going away for good reason, because they are harmful to watersheds and to the it's the people that are applying the chemistry on a regular basis that are taking it the hardest, because they get the most exposure. And so when we go to a golf course and we roll this out, the guy that typically applies the nematicides is very interested in what we're doing, because he doesn't want to mess with it. He doesn't want to deal with that chemistry. It's not good. You have to completely wear PPE. I mean, that gets your attention when the bottle says you have to completely mask up and get a respirator. And it's not good. It's not good.
I mean, I'm thinking, what about like, just typical lawn care companies, guys? They're treating for grubs all the time, and Japanese beetles and grubs. I hate those things in my yard, and they're all buried in my grass. I mean, what can you just take the DES and go right across and kill them?
Yep. Yeah. No, insects with the soil-borne phase are very, very easy. In Europe, we just got back from England. Went to a greenskeeper, kind of their regional annual meeting, and for them, because chemistry, has been more restrictive over the last 10 years than in America, they don't have a lot of synthetic options. As a matter of fact, this year, this is it. They're done using synthetic chemistry on turf, sports fields, horse racing tracks, cricket pitches, golf courses, all of it. No synthetic chemistry. And for them, the big one is crane fly larvae. They call them leather jackets. It's a big, in that phase in the soil, it's a very large worm. And really, it's the predators of the worm that create the damage. Crows, badgers, they come in and it looks like a bomb has gone off because it's a buffet, right? They just eat all these larvae. And that's a very, very easy target for us. We're used to working with, fungal pathogens that are microscopic, and then nematodes that are barely visible. So those really small pathogens and pests, that's what our profile is designed for. So anything that's technically like similar physiology but larger is just that much easier, because we can get more energy across them. And
I guess there would probably be a balance of some of that needing to use it. I mean, like, I do think there might be some need to keep worms alive. And so is there a risk by treating the soil that the worms would die if you hit them with this energy?
Yeah, I mean, there's certainly a broader spectrum effect. We're fairly tailored, especially when it comes to the root zone of the plant.
Yeah.
So we can tailor our profile to where the rhizosphere itself is, where the energy profile is above the threshold.
So you can like amp the voltage. So, it's either it penetrates the soil at a certain depth, or it's a shallow penetration. Is that correct? Or is that?
Yeah. What's really interesting is if you look electrically, the electrical conductivity of fallow soil, and then the electrical conductivity of the rhizosphere of the plant, there's so many nutrients, and there's this water layer in the rhizosphere. It concentrates our energy profile in that very tiny space. And so you can have a sublethal level of energy outside of that root, but the pest you're going for is actually in the root or sometimes in that rhizosphere. And so the energy profile is concentrated there enough to be effective, where if there's a free living organism that's outside of that, it's fine. And that's part of our selectivity, is we're able to dial that intensity to where we're just trying to get the target organism and kind of leave the rest of it alone. But to your point of earthworms, that's one of the biggest problems they have in Europe, because the ecosystem in a sports pitch is so contrived and it's so man-made that there is no balance. And so they just overpopulate to the point where they're a safety hazard and they're an agronomic problem for the turf itself. So, you try and help maintain that balance, or at least make it so they don't have to use such intensive practices to manage it. And, I mean, in natural ecosystems too, the other thing is when you put a chemistry down, there's persistence for 30 days, 50 days, 120 days of chemical action happening. Nothing gets a chance to recover until those things degrade. and are no longer active, we're there and gone. So it's literally a physical effect. It's instantaneous. And then you're back to the normal ecosystem without any chemistry that's latent there, or, you know, the constituents parts that it breaks down into that have 300 days of latency, you know, and then eventually end up in the water table.
Yeah.
I mean,
Yeah.
we avoid and sidestep all of that. And so the ecosystem has a chance to bounce back a lot more quickly after the treatment than it would otherwise.
No, yeah. I mean, there's so much. I mean, there's a lot of benefits from using this versus chemical applications. You know, it'd be interesting. Have you guys done any comparisons on maybe the cost of application compared to the cost of chemical application on a say a golf course green on average or something like that? So when you're making your value prop pitch to these guys, you're saying, look, this is what we're charging. This is how much you're paying if you did this. I mean, is that kind of what the level of marketing and support you're, you know, showing? And then the value of the end of the day is the sustainability aspect of it should outweigh the, you know, at the end of the day, a lot of the financial maybe gap between the two.
Sure. Yeah. No, the goal that we're shooting for is basically take one thing out of their budget and replace it with our technology. So they run a fumigant. A lot of golf courses run a fumigant regime for their nematode control, and we plan on coming in at exactly that price point. And you make an excellent point when it comes to the sustainability aspect of it. When a golf course uses, and again, golf course is where we're starting. How this applies, you know, down the road, we're going to learn. But for this initial market where we're headed in, that sustainability aspect, taking the chemistry out of the environment, you know, safer for labor, safer for the players.
Right.
That is a PR and marketing aspect that they absolutely need to exploit.
Yeah, you guys need to. Yeah.
You know, and so we're not shy about you know, that fact. And right now we're dealing with golf course superintendents and the guys, you know, the boots on the ground, if you will. But as we deploy this and as this becomes a little more, you know, mainstream, if you will, that's going to be a very important aspect of our job, is to educate those PR and marketing people to make sure that, you know, they're getting word out to their members, their players, and the stakeholders that are important to them, you know, just how important this technology is, and let that kind of drive the demand as well as the efficacy.
Yeah, I like that. I mean, it totally seems like one of the biggest advancements of potential. I mean, it is an advancement. I'd like to see this expand, like, you know, mass scale. I'm sure you guys would too. But I mean,
With some
I can
help.
see a lot of golf
Gonna need
courses.
a lot of help.
Yeah, and sports, you know, sporting events or activities. I mean, even lawn care. This has got such a big application potential across the many, you know, markets, right?
Yeah, well, and to go back to kind of how Jeff started this conversation about this pest management, really food security of the planet,
Yeah.
and going back and reclaiming land that's currently not arable because of these pests. You know, there's a specific nematode called a potato cyst nematode, and their over seasonal state is literally a cyst. It's a little kind of fingernail covered chunk of eggs. It'll sit there for 40 years until you plant the next crop that it wants to
Wake up and eat.
Yes.
Yeah. Yep,
So
exactly.
and even the harshest chemistries that we did have available, like methyl bromide, which is just an amazing soil disinfectant, right? It's almost a sterilant.
Yeah.
It's not completely successful in managing that pest.
Wow.
And in our research paper, that's one of, because our researchers like to challenge us, that was one of the organisms that we treated, was this cyst nematode, and we had great efficacy on it with this technology. So, you know, we can take this and actually go back and take land that's out of production and put it back in production, and do it in a way that doesn't involve all of the critical infrastructure and storage and transport. You know, it's a very small footprint box of electronics that can be, again, run off of a solar panel, let it accumulate enough energy to deliver a treatment, and then it just sits there. And you can, you know, square meter by square meter, even in a very challenging environment, use this to reclaim that land and make it arable again. You know, jumping straight to that isn't the best business model that we can come up with. because there's not a really generous revenue stream. And that's why, turf being so high value is why we're starting there. But we're firmly aware of the true implications of this when it comes to food security. We've got billions more people we have to feed in the next 50 years.
Yeah, right.
And, arable land, they're not making any more of it. So we need to go back and get some of that back.
So I did an episode a while back with Pete Pearson of the WWF, and he's in charge of, food waste and food security and things like that with the WWF. And man, I'll bet you he might have an idea of some sort of application, some need for you guys. I should connect you guys up with Pete to let him learn about your product here, because, there's so many good benefits for it. I mean, now is one application enough to really kind of solve the problem, or is it something where we got to come back and maybe do repeat treatments a bit, on occasion, or how effective is it in that, aspect?
Well, we've crashed populations entirely, and so the mechanism of reinfestation has to be reintroduction.
Okay.
Which it can come through irrigation water, it can come through on your shoes or on farm implements. So there's a cross-contamination sort of reintroduction. But in most cropping systems, just a level of suppression is sufficient. How hard do we have to hit it to completely collapse the profile? Depends on the organism, depends on the cropping system, depends on, there's a ton of variables in all of ag. But I mean, the potential is there to crash populations. We've done it in several field trials where, right now there's a golf course in Florida that was heavily infested to the point that they stopped using the green. They mowed the approach and put the pin in there because they were out of chemistry. They were out of the ability to apply any more chemicals to it until the next year. We came in, treated it 30 days later. It was the best green on their golf course. And 6 months later, it still looks great. And the population hasn't really rebounded yet. So we're keeping an eye on that one. But it's almost a case by case or cropping system by cropping system kind of a circumstance. But potentially, yeah, you can knock those populations back that are plant parasitic, that are, like we said, not already, completely out of balance naturally. And maybe there's a management level there where they can kind of coexist and co-compete, and try and restore a little bit of balance.
And this electricity that's being injected doesn't really have a detrimental effect to the plant's organism. Is that right?
One of our biggest challenges is maintaining the difference between, and it's referred to as phytotoxicity in the chemical world. So we use the same nomenclature. So we try and manage the phytotoxicity and still have our efficacy on the pest. And it's a balance. I mean, we can kill plants. It's one of the things we've tried to avoid in our development, right? You find that the edge between where the plant's damaged and the pest is damaged, and just stay in that place. And there's also some benefits that the plant has from having these pest profiles removed: increased vigor, increased health. So it kind of cuts both ways. I mean, even if we do a little bit of injury, because
you can replant, typically you can plant new seed and grow, right? And then
as soon as you pull that stress or that vigor loss out, it rebounds even faster than it would have otherwise. And so there's a little bit of room for some injury, but not much.
And the plants themselves are amazingly resilient. I mean, we've benchtop trials, the greenhouse trials we did down in Corvallis with our USGA research partner. I mean, we clobbered this tomato plant, just clobbered it, and it fell over. And a few weeks later, it grew back strong, produced a good crop, and it caught back up to its its partners, I guess, in that group of the study. So they are pretty resilient if you don't hit them too hard.
Oh, that's great. Well, talk a little bit about Lisi's patent. I mean, what's going on, or how does that? Have you got it registered with the EPA at this point, or you're still in the process, or how's that going?
Yeah, we're registered with the EPA. We're a non-chemical device. And they've acknowledged us. We have to remain registered with them. We just let them know how many units we have in production or how many we have out that are deployed. So they treat us a little bit like the chemical companies in that regard, but otherwise we've got free reign. The patent was an interesting process. Having never done anything like that before, it was a pretty steep learning curve, as you would imagine. But, that was granted back in 2018, and that was built around everything that we were learning from that first experiment in 2012 and on through to through to our filing. It's issued in the United States. We're currently working with Canada to get it issued there. We've got continuations on that patent. And then we filed a second provisional application middle of last year for the application device that we're deploying now in turf. We've got loads of others that are just kind of sitting there waiting for the research to get done. So we've got, excellent bracketing, if you will, of the technology and the inventiveness. But it just takes time, and it's long, painful, expensive, and not what either one of us want to be doing.
Yeah, you want to be out in the field testing and building
the
these
resident
things.
experts. You can't train somebody up to get that done. I mean, it's up to us to do it. But we understand how important it is from a corporate standpoint. It isn't our favorite thing to do. In fact, we loathe it. But we're doing our best to kind of check that box.
You can hire probably a lawyer to help you do that.
We've got one, yeah.
Okay. Yeah, I was going to say.
$320 an hour. You burn through your runway gets a lot shorter.
That's true. You got to be careful. That's true.
It's something that we're doing, just kind of because we have to. But,
I mean, you absolutely should, because you want to be the guys first on the market, and covering this. This is great. Well, what's been the client's response? I'm kind of curious to see, what have they said about the treatments, and give some stories there so the listeners can understand what's going on there.
Man, where do you start?
Boy. Yeah. Well, I mean,
and then maybe share a little bit where you've actually done some of this cool work that is very impressive in good spots, neat spots.
So we've spent a lot of time on the Monterey Peninsula. Those folks at that famous golf course there are a huge supporter of ours, and we've been down there doing research for years. So the superintendents down there just can't wait for us to come back, and they've actually pulled us out onto their playing greens and some of the most iconic greens in golf, because they have a pest pressure that they need addressed, and they're just like, get out here, we don't care, we need this. So we're on one of the Peninsula Country Club greens overlooking the ocean with the iconic tree in the background. And all I'm thinking is, God, please don't let me kill this green. Don't let me kill this green. This is going to be really bad. Because we had just rolled it out of San Diego. This was the first large scale deployment.
Right.
And we made some wonderfully green stripes in his green where he's like, okay, great. Thanks, you guys. Now we need to come back and do the rest.
Yeah. You've made a clean spot. Now what?
Yeah. The rest of my greens look bad. So you made this one look
well,
good,
even
right?
on that green, all he wanted us to do was treat a couple of spots where this particular pest was completely out of control and not responding to the chemistry. We fixed it, but then made the rest of the green look not that great. So he was suitably stoked and also a little disappointed.
Yeah.
And then I think Bandon Dunes is another golf course on the Oregon coast that asked us to come out, and they'd taken a green completely out of play. Fortunately, they had two for that particular hole. And they're at the end of their chemistry, they can't apply anymore. They're completely at the label limit. We came in, blasted through that thing in a day, delivered a really solid treatment. And that's another one of those greens that still looks great. And we asked the superintendent there a month ago, hey, how's it look? He's like, no nematode pressure, green looks great, still in play. Look forward to having you guys back. So they see the evidence firsthand and just can't wait to have us. And really one of our biggest challenges, and it's a good problem to have, is managing those customer expectations as we roll out, because we only can meet a certain amount of demand right now. You don't want to create too much hype in the marketplace and then not be able to fill the demand. And so, we're very selective on our rollout, but it'll build momentum and it'll come. And the enthusiasm we get from the food crop ag sector is more even than these guys in turf, because they really know the implications of it, and they're super excited. Small berry fruits, especially strawberries, raspberries, huge inputs, $8,000, $10,000, $12,000 an acre in mitigants that are put on that crop. to manage the soil pest profile.
When do you apply for like the strawberries? I have a crop of strawberries in my backyard. I've got a nice little, 4x10, raised bed,
Nice.
just chock full of strawberries.
Mhm.
But when would you apply that technology to the strawberries? Before you plant them or
Pre-plant.
after?
Yeah.
Pre-plant?
Yeah. So if you think about, and Indiana's a little bit different than like the central coast of California is where most of the like Driscoll and these huge strawberry companies have all their acreage. The issue there is fungal pathogens, verticillium, Phytophthora, Fusarium, and these are all stored or their bank is in the soil.
Mm-hmm.
And so eventually, as the fruit develops, the fungal pathogen gets up there, and then you end up with different types of what looks like mold or downy mildew or things like that. And so most people at that point are putting a foliar application of fungicide on the fruit just to protect it, to get it out through harvest. We just received results from a trial that we did with Fusarium that was in the soil, and we treated these inoculated bits in the soil and were able to control it in the soil, which the researcher we were working with is like, there is no chemistry that will do that. Methyl bromide used to do it because it's a disinfectant. They haven't been able to use that for years, and it's really impacting that industry. And we can treat it at its source and not have to do a foliar application of a fungicide, which now you've got food product that's got chemistry.
Yeah, you don't want that.
Implications there that aren't great. But really going to the source of where the pathogen is resident and treating it there. That's the solution. They know that it's coming. We're just doing the work. We should be doing strawberry trials out in the field, later this year, early next year at the latest. Because again, it's the demand. Like they have to have it. It's a huge industry. It's billions and billions of dollars.
Yeah.
And they're really up against it. So, I mean, I think if you talk about enthusiastic kind of adopters, those people that are really staring down the problem and know that it's just it's a slow motion disaster for their industry, they're the ones that are the most excited. And, and that's where we're going next in food is going to be small berry fruits for sure, because the need is there.
Wow. No, that's really exciting. So it sounds like, between the golf course community and, maybe some other sporting, organizations, I don't know, soccer, whatever. I don't know what other pitches you're applying this technology to. So, in the sporting community, that sounds great. And now this agricultural community is going to be a big. I think you got the residential lawn care community you can look at too. It sounds like a big one to me.
We were at the golf course superintendent show down in San Diego this winter. Basically, it was beginning of February, and there was one fellow there who's down in Texas, I think, and then that was his gig, right? He was a lawn care guy, and yeah, he chatted with us for quite a while. And I think he was
how soon can I get one of these?
Exactly.
Yeah.
And he wanted an answer, and he wasn't leaving until he got one. But yeah,
you're like, well, how much do you want to invest? I'll
exactly. Yeah. What's this going to cost, and when can I have
it's
it?
way more zeros than you want to write on a check.
We're currently sitting on 2. So yeah, it's going to be a bit of a wait. But for sure, Sean, it's the enthusiasm. Is the thing that really kind of keeps us going. It's fun to talk to the, these guys that are just right in the middle of it. And,
right.
We tell them what we're doing. And, when we first started out and we're telling them and they don't believe us,
right.
They kind of look at us a little skeptical. And then we start talking about the science. We start talking about the things that we learned in the field. And we start talking to them the way that they talk about their industry.
Right.
And so we build the relationship like that. We speak to them in their language. We show them the data that we've generated, and we're not woo. There's a ton of woo, especially in golf, where you've got tees and all these things that they'll roll out to these golf course superintendents at these trade shows and things like that, and they'll buy into it. They'll spend hundreds of thousands of dollars to have this stuff applied to their golf courses, and none of it works. Literally, none of it works.
Right.
So when we come to them with the data, here you go. We've got a published review, peer-reviewed publication on the website. Go take a look at it, and then the phone starts ringing. It's like, how soon can you guys get out? I mean, that's how we got Bandon Dunes, knocking on our door. Come out and give it a try. Well, this and that, we don't care. Come out and give it a shot. Because we need something.
Yeah. I mean, they're like, hey, you're my last resort now. Obi-Wan Kenobi, come help me.
Yeah. Well, and the next step is renovation. So they basically strip the turf up, treat the soil or haul in new soil, and redo the entire green. And that's tens of thousands.
That's
really
expensive.
amazing.
No, that's expensive too. I mean, just looking at this from the technology perspective, it's really cool. And then I think overall the sustainability approach to this, I mean, the sustainability benefits of this is just huge when you think about it. And I think that anybody who sees this technology and doesn't take into account that part of the benefit of purchasing your product or your service basically to do is, I don't understand. I mean, it's like a no-brainer in my mind. I'm looking at this going, wow. Well, how can you guys, what's the plan to scale this technology in the market? I mean, what do you got? I mean, I know you're doing these trials and you're building the experience summaries and stuff, but I mean, anything more than that you guys are looking for to scale this thing?
Yeah, absolutely. I mean, we're at revenue in May, so we're delivering it as a fee for service through a channel partner. We've got a local distributor in South Florida, and he does this sort of work with these golf courses already. Will just be another arrow in his quiver.
Gotcha.
To help them manage these issues, and so I mean that's going to scale and revenue, start generating some positive cash flow, while we build more units, while we deploy into other areas that still have turf needs. So, kind of staying in that industry. But then, I mean, next week, we're doing a research trial in a hop field. It's in our neighborhood, and 90% of the hops in the United States are grown just down the road from us. And those guys have a huge need. And so, as a path to revenue, that's our next spot because it's in our backyard. What they're asking us to treat is actually pretty simple. We've got a researcher from Oregon State that's kind of spearheading this effort. But I mean, that's our next opportunity for revenue. And you just keep doing that. You keep building units. You keep scaling up your cash flow. Obviously, we're looking for a next round of funding because this is how all entrepreneurial companies are. So once we're at revenue, we've got some really good business models going. Then we go out and get a bigger raise, scale it even more. The engineering for the electronics never stops. So we had to stop at some point and then start making multiples of these. And, it's based on 5-year-old designs and engineering that we're currently putting out. So that's continuing on. It's going to be smaller, more powerful, more energy efficient. Like we've already got the next 2 iterations, at least on paper.
How about any handheld devices? You can do some spot treatment.
Yeah, I mean, you can do that. Be very careful with what you're doing, but you can do that. It still requires the energy storage box and the actual generator, but very easily into a hand deployable spot treatment device. And as we said, as the semiconductor technology that this is based on didn't even exist 3 years ago. It's really an offshoot of electrical transportation. So these switches that we use are really designed to be in traction motors for trains, dump trucks, buses, that level of energy control. And so we've just co-opted this semiconductor technology that's been developed for other aspects of, the electrification of our transportation. And that is continuing on. The switches that we used for the previous version, we imported them from the manufacturer in Germany. They were the first 2 that got into the United States. This was 6 years ago. 8 years ago.
This was pretty early.
The first 2 that entered into the United States, we had to go see Department of Homeland Security because they're those kind of devices.
They're like, what are these things?
Well, they know what they're good
for.
That's why they wanted to talk to us.
Why do you only have 2? Sign this. So we know where you are.
So we got the first 2 that this huge multinational imported into the United States by working through their engineering development team. 2 years later, they were obsolete and replaced already with a new device. So that technology moves at just light speed.
Sounds like the iPhone.
No, it's very, very rapid deployment. And because again, the need is there for the electrification of our transportation. The renewable energy sector uses these things in mass quantities. And so we just piggybacked along for the ride, basically, and let them drive our technology. We just got to figure out how to do the application. And the same thing with the batteries. Our battery pack is this latest iteration. We lost 30% of the weight, about 20% of the volume, and increased our capacity for the same dollar per watt hour.
Have you thought about buying one of those Tesla battery packs?
Yeah, we looked at that. They're kind of large and ungainly. I mean, we could manage it, but what we've got is much easier to work with. It's much more modular.
Gotcha.
And we've got a really similar energy density. It's surprising how much is really out there. We've got a wonderful battery supplier that we work with that works directly with the manufacturer, and they've been super supportive.
Man, this is, I mean, I'm excited. I want to see this thing in action. I want to see some like before and after results. I know on your website you got a few of those showing, but I can only imagine, over the next, year or so, the more case studies from a before and after PowerPoint presentation is going to, surface somewhere, and we're gonna be able to like do a slideshow and show that. And so that'll be like the proof's in the pudding, right?
Well, and we're actually headed through the Midwest. Not
when
next
you coming?
week, following week. At the end of the following week, we hope to, at least be somewhere cozy in a hotel in Indianapolis, or maybe a little further east.
Oh, well, when you come, let me know, guys. I want to connect up and meet up, because I know that, Jeff, you've got those IRL cart routes, so you've got some reason to come back to the 500 sometime in May. So
I've actually already booked myself out, so I can't be tempted to go back. It's domestic tranquility at this point. I can't do too much other stuff because this is taking a lot of time.
I understand completely.
But, we'll get back and kind of touch base with the home crowd there, because it's been a little while, at least for me, since
absolutely. Well, I mean, love to connect up when you guys get back in this neck of the woods. I'm over here in the west side of Indy, so
perfect. We'll let you know when we're coming through and where we'll be. It may be closer to Columbus. We've got some feelers out for where we might be able to apply our treatment and kind of demonstrate what we're doing, but we'll make sure you're in the loop. And
you need to go to Brickyard Crossings.
That's a good idea.
Come on.
I used to know the guy that ran the place, but people move on, right? So
let's get there. Go to Purdue. They've got the Pete Dye courses up there. I mean, they do turf technology education at Purdue. Man, that'd be another great, hotbed of case study support over there.
Yeah, for sure.
What's interesting is in those climates where they have 4 actual seasons, that's a natural suppressant for a lot of these pests that we're treating. This is why South Florida and the West Coast of the United States is such a train wreck when it comes to these pest profiles, because there isn't any kind of cyclic suppression seasonally to control these populations. And so they just keep growing year after year after season. And eventually it becomes, detrimental to the crop to the point you can't grow it. And that's where they get, really extreme with cultural practices and the extreme application of the chemistry.
Yeah,
you're standing on the Monterey Peninsula, you're looking out at that beautiful ecosystem and the amazing things around that Monterey coastline. And these guys are having to manage these soil pests with a lot of pretty harsh chemicals. And it's their home too, right? They get it. They don't want to
over chemicalize, over apply, and
and it's a real personal concern for them. And fortunately in the Midwest, that's not really that big of a concern for turf. They do have insects.
We have insects and pests, so let me tell you,
it's the grubs and things like that are really a difficult pest to manage. And you don't want to put a lot of harsh chemistries on sports fields where kids' faces are being rubbed into it.
Another reason why, this is a great alternative to chemical treatment. So, I mean, awesome. This has got lots of potential, guys. I mean, I'll do what I can to hype it up on my end, but let's stay connected. And I really appreciate you guys coming on the show today and letting listeners know a little bit more about Lisi Global and your, direct energy system technology and what the application can do or what this device can do for, agriculture and, also, turf, applications. I think it's, controlling these pests in the soil can really be a great thing for the environment. And man, it's such a sustainable option. I really love it. So
Global food security, that's where we're headed, Sean.
Global food security. That's
the thing
awesome.
we will never lose sight of.
No,
we're running around on golf turf right now, but
we're going to get more. Yeah. The global food. I mean, I just can't believe you're not getting a lot of interest from some of the big ag companies thinking, let's do something with you guys.
We're way under the radar as far as, and way too soon as far as those guys are concerned. If they, what they do know about us, they're waiting for us to get a little further along, I imagine.
Yeah.
But you're right. And we're keeping them in the loop. We're making sure to make enough noise that they know we're here.
Yeah.
But we've got a long way to go in terms of scale. But as that goes, and the more noise we make in turf, more and more will be paying attention. So
yeah,
it's coming. It's coming. We're feeling pretty good about it. We're just getting started.
Well, this is great, guys. Good to have the call today. Get in touch with me when you come into town. I'm looking forward to meet up with you guys. Absolutely. And maybe try some hops. And we'll sure. we'll treat those while you're out here.
You got it. Absolutely.
All right, guys. Have a good night, and we'll talk to you soon. I'll get this out soon.
All right. Thanks, Sean.
Yeah, thanks, Sean.
Yeah. Bye.